Hello there, I'm an old guy and I do maths. And today we're looking at what does the expression no solution or no solutions really mean, and whether or not we can spot it. Okay, now what it really means is that sometimes there's what's called no real solution for x when it comes to factorizing a quadratic. And we can see this in the graphs if we know what to look for. So let's have a look and find out what we need to look for. Okay, so I've got four parabolas roughly drawn on this rough Cartesian plane. And what you can see is that two of them, this one and this one, do not touch the x-axis. Now, what that means is that they have no real solution for x. I'm just going to call it no solution for x. And it doesn't mean that they don't exist. They have a perfectly viable existence. They have their own equations. And just to demonstrate that, let's have a look at this one. So let's say that we'll put this in turning point form. So this equation might look like this. Maybe something like x minus 1, which means that if we had a parabola here, it's been moved 1 unit to the right, and obviously this has been moved up, so we'll move it up, shall we say 2. Okay, now this can be expanded to look like a quadratic trinomial, and we need to put the squared in there. So this is x minus 1 all squared plus 2. That's turning point form. It can be written in other forms. But this thing has no solution for x because it doesn't touch or go through the x-axis. Same thing here. So what's happened to this little parabola here is that it's been inverted, moved to the left and down. So it's a series of transformations and translations, reflections, call it what you like. And what might this look like? Again, we'll do this in turning point form, because this is the form in which it's really fairly easy to spot these. And let's say that it's been moved 2 to the left. Okay, so that's x plus 2 all squared, and down 1 for argument's sake. I'm not suggesting that any of this is to scale, and it's been reflected in the x-axis. Okay, so that's all of the things that have happened to it. But the main point is that at no stage does it touch the x-axis. You'll see that both of these do touch the y-axis. No problem with that whatsoever. Now, let's have a look at these two. Let's start with this one. So this touches the x-axis at one point, which suggests to me that this is some form of perfect square. Now it's been moved to the right a number of units. We'll say 3 units. And it's negative. That's completely coincidental. This could just as easily be positive, and its equation would be x minus 3 all squared. Okay. When you draw this, you find that it touches the x-axis. It's got a real solution for x, one solution. It's easier if we look at this one. And what we'll see is that if you were to do what this suggests, you would get x minus 3, x minus 3. In order to make each of these brackets equal 0, you just have to make x equal 3. So there's one solution for this. Okay, over to this one. This thing hits the x-axis twice, goes through it. And again, let's just make up some numbers. We'll put some numbers in here so that we've got something to work with. And in that case, the factorized form of this would look like this. And by the way, if any of this is a bit of a mystery, have a look at some of my videos on factorizing or turning point form, any of those, and it'll become apparent, hopefully, what it is that I'm doing. Okay, so in order to make these brackets equal 0, x has to equal -5 or -3, and we can see that these are the x-intercepts. And therefore this thing does have solutions for x. It's got 2 of them, hence the s in brackets up here. This one, for instance, only has 1 solution, and of course this and this have no solution or solutions. Now another way in which you might see this written is like this: x squared plus 8x plus 15. And this is easily factorized. When you see it in this form, you can just say, well, the factors of 15 are 5 and 3, and they add 2 to 8. And so you can factorize it like this. You can see it in expanded form, and it's fairly obvious that this thing is going to have a solution for x. Now, I think that is all I want to say before we move on to something a little more elaborate. Okay, let's do that. So I've got a quadratic here in turning point form and fully expanded. Okay, now in turning point form we may be able to spot that the parabola that this thing graphs has a minimum, a turning point at +2 to make that bracket equal 0, 3. Now that means that is the lowest point of that parabola, the turning point. I've graphed it roughly down here for you to see. That is the y-axis, that is the x-axis. 2 along, 3 up. Doesn't go near the x-axis. No real solution for x. Okay. Now, let's just say that you expanded this, and you got this function here, x squared minus 4x plus 7. And you decided to go looking for a solution for this. Or you decided that you would try and factorize it by completing the square. Well, you can see the working here. We create a perfect square here. And we do that by halving this number and squaring it. Should probably put that outside the bracket. I don't know if it matters in this case, but we'll do that. -2 squared will be 4. -2 squared will be 4. And what we wind up with is this, which is of course what we started with, but we were working from this point. We should be tipped off at this point that there is no real solution for x, because when we look at this, we see that this is what the graph would look like. Now, we can go another route with this, and that is to use the part of the quadratic formula that is called the discriminant. And it's this little piece here. Now, if this turns out to be negative, there's no solution for x. Now, this is covered in another video. You might want to have a look at that. Anyway, let's go ahead and do this. So b squared is -4 squared, that -4, minus 4, sorry, b squared is, oh, get this right. b squared is negative 4 squared minus 4 times 1 times 7. Negative 4 squared is 16. Negative 4 times 1 times 7 is negative 28. That is less than 0. This thing has no real solutions for x. Thanks very much for watching. Errors and omissions accepted. I'm sorry I stumbled there. I'll see you next time. Bye-bye.